Hello my dear students from grade 6. How are you? I hope you all are doing well. Welcome back to our new video lesson. Topic 16, Lesson 3, Measures of Variability. My dear students, kindly pay your attention to the following instruction from the teacher. Instruction number 1. Study the video lesson very well. Instruction number 2. To complete your assignments as per the weekly plan, log into your account on pearsonrealize.com. Alright? Before going, dear students, bring out your textbook, copybook, pen or pencil, and highlighter pen. Thank you. Alright? Review questions, today. First review question, are you ready? Very good. The data displayed in the box plot represents the ages of 11 children attending a family holiday party. Which could be the data set used to create the box plot? Options. A. 2 10 4 3 3 6 7 7 9 5 10. B. 2 4 10 6 8 5 5 10 3 5 4. C. 8 10 5 6 3 6 3 2 7 6 10. D. 2 8 8 7 4 6 4 0 2 7 8. What is your answer? Very good. Option C is the correct answer. Why? Let's explain. What is a box plot? A box plot shows a distribution of data values on a number line. To describe a box plot, we need to find the following values: the median, the middle data value, the minimum value, the least data value, the maximum value, the highest data value, the lower quartile and the upper quartiles. The median is the middle value of the ordered data. The lower quartile is the median of the lower half of the ordered data. And the upper quartile is the median of the upper half of the ordered data. These specific points of data values will tell us how much the whole data has a spread over the data values. A box plot helps us to know this by a simple diagram like this. We understand that only the third choice after we ordering the third choice of data, the box plot above exactly matches. So the answer is choice C. 2 3 3 5 6 6 6 7 8 10. Great. Now, our second review question is: which of the following is not a statistical question? A. How tall are the players on a basketball team? B. What are the favorite colors of the teachers at Lincoln Middle School? C. What were the snowfall totals in Chicago for the past 10 winters? D. Who is the Chief Justice of the Supreme Court? Which is your answer? Very good. The correct answer is option D, who is the Chief Justice of the Supreme Court. Let's check why. What is a statistical question? Great. A statistical question anticipates, the person who asks, knows already what will be the answers before asking, but expected to have more than one exact answer, that there will be a variety of answers. Choice D, is a question that have exactly one answer. So this is not a statistical question. But for other questions, expected to get a variety of answers, are statistical questions. Clear? Great. Alright? Dear students, for more review questions, you need to log into your account on pearsonrealize.com. Take printout, try to find answers and keep the paper in your portfolio. Submit your work to the teacher later. Thank you. Alright my dear students. Now, we are properly on our lesson. Our today's objective is: we can use measures of variability to describe a data set. Again, We can use measures of variability to describe a data set. Good. Now, we have a question here, for which you should find the answer, and share your answer with me. Our question is: suppose you collected data from 11 people about the number of letters in their first names. The median name length is 6 letters. Make 2 possible dot plots that could be used to display the data, one where the data varies a little and one where the data varies a lot. Solve this problem any way you can. You can use reasoning to find values that have the same median. We are going to collect names of some students now. Okay, let's collect the names of 2 groups of students, groups of 9 students in each group. Are you ready? Let's go. Well done, dear students, you have collected the first names and noted the number of letters in each. We are planning to make a study on the name length. Alright, now let's arrange these data using a table like this, then we need to order the data. We have to construct a dot plot now. What is a dot plot? Very good. A dot plot is a diagram to represent the data values using dots on a number line. It can describe the spread or variability of the data. Okay, let's make a dot plot for our data now. For this we need to order the data and then draw a number line and start putting dots one above the other as per the occurrence of each data value. Let's make dot plots for each data set and compare. Which data is more spread over the data values? Good, our second set of data values is more spread than the first set of data values. Great. Okay, dear students, now let's discuss look-back question. Describe the data distribution you generated and discuss the spread and clustering of the data. Very good. In my dot plot where the data varies a little, the dots were all clustered close to the median, 6. In my dot plot where the data varies a lot, they were more spread out. Is it clear, dear students? Good.
How can variability of data be described with one number? Think about this question during the lesson. The center of the data for Anne's math quiz scores can be described using a single number. How can a single number describe how much Anne's scores vary from the mean? What measure of variability do you already know?
Variability describes the spread and clustering of data in a set.
The range is a measure of variability. How do you find it? In general, how is range related to variability? To find the range, subtract the minimum data value from the maximum data value. The bigger the range, the more the data values are spread out. Here is another measure of variability. Step 1. Find the absolute deviation, the distance between each data value and the mean. You can find the absolute deviation from the mean by computing the absolute value of the difference between these numbers. Why do you find the absolute value of the difference between the data value and the mean? You are finding each data value's distance from the mean, so you use absolute value. Step 2. Find the mean absolute deviation, MAD, the mean of the absolute deviations of a set of data. Add the absolute deviations and divide by the number of data values in the set. Generally, Anne's quiz scores varied 6 75/100 points from the mean. Suppose all of Anne's quiz scores were in the 80s, but the mean was still 86. How would the mean absolute deviation change? The mean absolute deviation would be less than 6 75/100ths because the scores would be closer to the mean. Now you know how variability of data can be described with one number.
All right, dear students. Now tell me the answer for this question. Can the mean absolute deviation, MAD, ever have a negative value? Explain. Very good. No, since the absolute value is taken to find the absolute deviation, the MAD can never have a negative value. Dear students, let's have another example now. Kindly open your textbook page 799. Another example, we have this data, and science quiz scores. The scores are given as percentages, 78%, 79%, 80%, 81%, 82%, 83% and 84%. How does the interquartile range describe an science quiz scores? The variability of the data is shown as a box plot here. Another measure of variability is the interquartile range, IQR. This is the difference between the third quartile and the first quartile. Because at least half of the data values lie in this interval, it is easy to see the interquartile range using a box plot. The dot plot shows AN's quiz scores for science. The interquartile range is 82-79 equals 3. So, at least half of AN's science quiz scores were within an interval of 3 points. Good. Now guided practice, first part, do you understand? Question number 1. What does the MAD tell you about the variability of data in a data set? What is your answer? Very good. It describes how far a typical data value is from the mean. Question number 2. What does the IQR tell you about the variability of data in a data set? Great. The IQR tells you how far the values in the MIDI portion of the data are spread out from the median. Now guided practice part 2, do you know how? Read the direction, in 3 and 4, use the data set. 4, 5, 5, 6, 7, 8, 8, 10, 10. Let's make the answers for both questions together. Number 3. Find the sum of the absolute deviations from the mean. And number 4, find the MAD and the IQR. Excellent. Answers, number 3, 16 and number 4, MAD equals 1.7 and IQR equals 4. Let's check how. First, find the mean. Mean equals 4 plus 5 plus 5 plus 6 plus 7 plus 8 plus 8 plus 10 plus 10 divided by 9 equals 63 over 9 about 7. Then, we need to find the absolute deviations. For this, let's construct a table of 2 columns and as many rows as the number OD items. In the first column, enter the data values, and in the second column, we have to find the absolute deviations of each data value from the mean. Remember, all the absolute deviations will be positive. It's the absolute value of the difference between the mean and each data items. Now, find the mean of the absolute deviations, which we call as MAD. MAD equals 3 plus 2 plus 2 plus 1 plus 0 plus 1 plus 1 plus 3 divided by 9 equals 16 over 9 about 1.7. So MAD is about 1.7. Okay, now let's find the interquartile range, IQR. How? Very good. For this we need to find the upper quartile and lower quartile. The data is already ordered, we don't need to order it again. Lower quartile equals 5, median of lower half, upper quartile equals 9, median of upper half. So, interquartile range, IQR equals upper quartile minus lower quartile equals 9 minus 5 equals 4. Very good.
Using this set of numbers, we are going to discover how far they are spread out from their mean by calculating their mean absolute deviation, MAD. First, we find the mean of the dataset. So, we add the numbers for a sum of 150. And then divide by 5, the number of values in the set. The mean is 30. Now, remember this mean, because we will use it to help us find the absolute deviation of each data value. We start with the mean we just found, 30, minus the first data value, 15, and record the absolute value, 15. Let's calculate the next one. Start with the mean, minus the second data value, 20, then find the absolute value. The absolute deviation of the data value, 20, is 10. Let's do one more together. The mean minus the value, 30, is 0. We follow the same procedure for the rest of the values in the dataset. We have a list of each value's absolute deviation. Now, we can calculate the mean absolute deviation, MAD. So, add the absolute deviations together and divide the sum, 50, by the number of values, 5. And we find the mean absolute deviation, MAD, of this dataset is 10.
Okay, dear students, independent practice now. Read the direction. In 5 and 6, use the data table showing the number of miles Jill biked in 9 days. Kindly take a look at the data values in the right. Miles biked, 5 miles, 9 miles, 11 miles, 10 miles, 8 miles, 6 miles, 7 miles, 12 miles and 4 miles. Now try to find the answers of 5 and 6 together. I will give you 3 minutes to find the answers. Start now. Okay, time's up. Stop writing. Tell me the answer of number 5 now. Find the absolute deviation from the mean for these data values from the set, 5, 7 and 12. Very good. 3, 1 and 4. Okay, answer of question number 6, find the MAD of this data set. What does this tell you about the number of miles Jill biked? Excellent. 2.2 repeats, which means about 2.2, the number of miles Jill biked each day varied by about 2.2 miles from the average. Great job. Now, let's solve some problem-solving questions. Let's open page 800 now. Are you ready? Very good. Read the direction. In 7 to 10, use the data set shown in the table. Okay, we have the following data table in which temperatures, in degree Fahrenheit, is given, 11, 17, 20, 16, 19, 16, 15, 22. Let's make all the 3 questions 7 to 10 together. First, number 7. The data show temperatures recorded during an experiment. The temperature of a chemical mixture was recorded in degrees Fahrenheit every 5 minutes. What was the mean temperature for the mixture? Very good. 17 degree Fahrenheit. Number 8. Dina said that the greatest absolute deviation will be found from the greatest temperature, because it has to be the farthest from the mean. Is she correct? Explain. Great. No, in this data set the lowest temperature has the greatest absolute deviation. Dear students, is it clear from the table that we prepared now? Good. Now, tell me the answer for number 9. What is the term used to describe the range of the middle half of the data set? Find that value for this data. Excellent. IQR, and IQR equals 4 degree Fahrenheit. How? Order the data first. 11, 15, 16, 16, 17, 19, 20 and 22. Lower quartile equals 15 plus 16 divided by 2 equals 31 over 2 equals 15.5. Upper quartile equals 19 plus 20 divided by 2 equals 39 over 2 equals 19.5. So, IQR equals 19.5 minus 15.5 equals 4. Good job. Number 10, which is an higher order thinking question. Are you ready? Great. Our question is: what is the MAD for the data and what does it tell you about the temperature of the chemical mixture during the experiment? Excellent. 2.5 degree Fahrenheit. During most of the experiment the temperature of the mixture varied approximately 2.5 degree Fahrenheit from the mean temperature. Our today's last question now. Number 11, Harlow recorded the tide, in feet, every hour during an 8-hour period as shown below. Take a look at the following table. Tide, in feet, 3 feet 7 feet 11 feet 15 feet 20 feet 31 feet 39 feet and 42 feet. Question, Part A, what is the MAD for the data set? Very good. 12.25 feet. Good job. Let's move to Part B now. Is the IQR greater than or less than the MAD? What does this tell you about the variability of the data? Excellent. The IQR is greater than the MAD. 3. The middle 50% of the data is spread out more than the average variation. Okay dear students, we did it. It is the end of our today's lesson. I hope you understood all the facts we discussed in this video lesson. So, try to solve the questions on pages 801 and 802 of your math textbook. Thank you. Wishing you all the best. And see you later. Bye.